Okay, good afternoon, everyone. My name is Jiang Wuxi, and I'm from East China Jiao Tong University. I'm so glad to be here to have this chance to show my results to you. And today we'll talk about something like study on functional adhesion coefficient of high-speed wheel-reel rolling contact. At first, let me talk about something like the research background. I'm studying about the vehicle track coupled system based on wheel-reel spring damper model, and then we can use this formula to calculate something. So the coefficient, the adhesion coefficient is very important to calculate. How calculate it? At first, Zhang Weihua commented other adhesion experiment on the basis of rolling vibration test bench, acquiring the calculate relation of adhesion coefficient of creepage, fitting the functional adhesion coefficient on the basis of water pollution in experimental speed. But the influences of different surfaces in contact haven't been taken into account. And the Takalka Y fitted the experience formulae, showing the relation of adhesion coefficient and creep velocity, fitting the wheel-reel surface condition with relative constant coefficient, which also limited the application of the formula. This paper adopted a GPM30 type rolling contact test machine based on the changes of roughness when the wheel rail was under the circumstance of contacting surface. Used the model of a BP neutral network to optimize the experience formulae of Japan's Shinkansen adhesion creep velocity. The functional model of high-speed wheel-reel rolling contact adhesion coefficient is built. So at first, I tracked and measured the surface roughness and hardness of CRH2 high-speed train wheels of D2260 train number. Under different operating matrix, the measuring point is the deepest wear of the wheel profile and the main contact spot, in which the direction of roughness measurement is the longitudinal of the train. The index is RA, and the grouping method is shown in the table below. And the hardness measurement values are all in the range of 60-100. And then as a test schedule, the outer diameter of the sample is 60 millimeters, and the inner diameter is 30 millimeters, and the sampling location is at 2 to 3 millimeters from the main contact spot at these pictures. And then the test load is calculated as 3,180 about Newton. In order to avoid the loss of generality, and the control spiral speed group was divided into 300, 1,600, and 1,600, 900, 1,200, and 1,500, and obtained discrete data of adhesion coefficient and creep speed under different conditions. And then each test time is less than 1 minute, and the temperature of the contact surface is stable below 50 degrees. According to the relevant literature, the change of the temperature range has little effect on the adhesion coefficient. And then the first result, when the creepage increased from 0 to 5%, the adhesion coefficient increases and the overall slope decreases, which is consistent with the experimental results in the literature. According to the graph, the relationship between adhesion coefficient and creepage under clean and roof conditions is less affected by the speed class. Therefore, 300 is taken as the speed standard in the follow-up test. And it can be considered that only the roughness of the contact surface of various specimens has an effect on the adhesion coefficient. And the second is numerical analysis. Based on the exponential function fitting, the roughness is taken as the correction coefficient based on the creepage change. And the BP neutral network is used to train the data, and the latter is true. And the optimized foundational adhesion coefficient is obtained. According to the duration of roughness, adhesion coefficient, and wear loss, the optimal roughness is selected as the operation and maintenance guide standard. Okay, the conclusion is the friction mechanism of wheel rail is very complicated, which is affected by many factors. This paper mainly analyzes the change of adhesion coefficient number under different speed level and different wheel surface roughness, and optimizes the empirical formula of adhesion coefficient creep speed based on BP neutral network. The main conclusions as follows. Okay, and in the process of creepage increasing from 0 to 5%, the adhesion coefficient increases, but the slope decreases obviously. Then relationship between adhesion coefficient and creepage is less affected by the speed grade under clean and roof conditions. The least square method is used to fit the function formula of wheel roughness, adhesion coefficient, creepage, and the BP neutral network as used to verify and optimize it. Okay, and the third one, I thought maybe it is not on the PPT. With the increase of wheel roughness, and the damage increased, and the contents of C and O first is carbon and oxygen first increased, and then it decreased. I thought it maybe I missed. So, thank you.